Talking about area of regular polygons. So number one, we said to find the measure of the central angle of a regular polygon with 24 sides. I do what?
360.
Good. 360 divided by the number of sides, which in this case is 24, which is 15 degrees. Good on that one, right? Easy stuff? Yeah, okay. Number two, find the area of the regular polygon. So for these, the area formula, if it doesn't ask for area and perimeter, then I can go straight to area, which is 1/2 ANS. So I have to know A, which is the apothem, and the number of sides, S, the length of each side. Which one do you know as soon as you know what shape it is? The number of sides. So this is how many? 5. This is a pentagon. Okay, and then this one also gives you what? The length of each side, which this one would be 8. It's a regular polygon, which means they're all 8. And the apothem, which it should have a little right angle, but that on your test it would be there. Okay, that would be 5.5, so that's your apothem. So this one you had all the information you needed. 1/2, 5.5 times the number of sides times the length of each side. So 0.5 times 5.5 times 5 times 8. And I got 110. This time it gave me a unit. This would be centimeters squared because it's area. Questions on that one? Okay, then we've got the area of a regular polygon. This time, again, you've got the apothem, but you have the radius instead of the side length. How many sides does this have? 6, which makes it a what? Hexagon. So these can be done without a calculator. These will be left in exact answer format. You should not be using root 3 in the calculator. You won't be rounding these, okay? Hexagon, triangle, square are like that. So if I start this out, I want to find that top central angle. So I would do 360 divided by the number of sides, in this case is 6, which puts that top angle at 60 degrees. As soon as I draw the apothem down, I cut that 60 into half. So now I've got two 30, 60, 90 triangles. So I'm going to pull it out just so it's a little bit bigger. This is 30 at top, this is 60 on the bottom left, and this is 90. Alexis.
Wait, how'd you say that the top angle was 60 again?
You do 360 divided by 6, because that would be your central angle, and then you got to cut it in half with the apothem. So every time you do one of these, you start that the same way. So the radius, which is the hypotenuse of this 30, 60, 90 triangle, was given to you at 12 centimeters. The side opposite 60 is 6 root 3. In a 30, 60, 90 triangle, and I'm going to do it in terms of x so we don't confuse the A for the apothem and the A for the combination. This would be x, opposite the 30 is x, opposite the 60 is x root 3, and opposite the 90 is 2x. So either way, whether you use the side opposite the 60 or you use the side opposite the 90, I get x is what? 6. So this little piece is 6, which is the half of this whole side, making the S what? And then the apothem they gave you was 6 root 3. So again, it didn't ask for perimeter and then area. I'm going to go straight to the area. Area would equal 1/2 the apothem, 6 root 3, the number of sides, which is 6, and the length of each side, which is 12. So I can do half of 6, which is 3, 3 times 6, which is 18, and 18 times 12, which is 216. And then the root 3 goes to the end. Units here is centimeters squared. So when we say exact answers, that's what it means. Don't use root 3 in your calculator. Don't round that, okay, to a decimal. Alexis.
When you do the like you got rid of it first.
Yeah, you can do that in any order because it's multiplication. I could have done 6 times 6 times 12 and then cut it in half. I could have done half of 12 and done 6 times 6 times 6.
Well, did when you put it in half, did you only put one number?
Yeah. So it's not, there's no addition. If there was an addition sign inside the parentheses, then you distribute the half to more than one. But because it's multiplication, it only gets one. Questions on that one? Okay, 4. Now it says find the perimeter and the area. So we're going to start with perimeter being n times s. And then we're gonna go to area being 1/2 A times P, so apothem times perimeter. This time there's how many sides? 8. So this is not one of my special ones. This is the one that you would have a calculator for, and most likely we'll be doing trig. So if I were to draw the central angle here, this would be 360 divided by 8, which is what? 45. That's the big angle here. Cut it in half with the apothem, and that top angle is what? Good, 22.5. So I'm going to draw it next to it. 22.5. The 15 is the apothem. I don't need the radius, but I do need this little side, which will end up being half of my s, right? At the end, I'll double it. So in respect to the 22.5, x has what location? Opposite. And the 15? Adjacent. Which trig function is that? Good. So the tangent of 22.5 equals x over 15. And then in the calculator, I would do 15 times the tangent of 22.5. And I get x is 6.213 and so on and so forth. But again, that's half my side length. So I would double it to get the s. And then the apothem's the one that they gave me, 15. So perimeter is number of sides times the length of each side, which is 99.2. And the area would be 1/2 the apothem, which is 15, times the area, times the perimeter, which is 99.2. Which is 744 inches squared. So perimeter is just in inches because it's length. Area is in area would be inches squared because it's area. Questions on that one? All right, so yesterday okay, number 5 says find the perimeter and the area of a regular polygon. What shape is this? Square. So this is one of the special ones. So again, perimeter is n times s. Area is 1/2 a times p. A, n, s. We know it's 4. The measurement they give you this time is what? It's the radius. So be careful because it doesn't stop at the end. This whole thing would be the same thing as here. So it's actually the radius. So if I were to draw the central angle, 360 divided by 4 is 90. That's this whole thing. Cut it in half with the apothem, and it's 45. Good. So the radius is 4. This is 45, 45, 90. So with a 45, 45, 90 triangle, my sides are A, and A root 2. I'm going to make them X just so we don't confuse them with our apothem. So if 4 equals X root 2, and I divide both sides by root 2, and then I rationalize it, and then I simplify it, I get that the apothem and half the side would be 2 root 2. So apothem would be 2 root 2. Half the side would be 2 times 2 root 2, or 4 root 2. So the perimeter is the number of sides times the length of each side, which is 16 root 2. And the area is 1/2 2 root 2 times 16 root 2. So 1/2 and 2 cancel out. That would be 1. What's root 2 times root 2? 2, and then 16 times 2 is 32. Meters squared and meters. So I told you this yesterday, but the reason why I pushed through yesterday is now you're on day 2 of this instead of day 1, and then tomorrow we can review. Then by the time you go take your test, you've had this for 4 days, okay, instead of just the 2 that you would have had if we, or 3, that you would have had if we started it today. So tonight you're going to do your chapter review, okay? I'm going to go through quickly right now with you the formulas that you need to know for each section. The good news is it's only 4 sections, really. It's 3 and then the one that we added in. And a lot of the one that we added in is review, like you know, area of a triangle and a rectangle and that kind of stuff. It's just adding this stuff to it. So tomorrow I'm going over the review. I wanted to be able to at least have a day to do that before you take your test. So if you want to open up a note or add to the warm-up, I don't care how you do it. This will be 11.1 through 11.3 with the areas that we added in. .1 was circumference and arc length. So circumference is 2 pi r or pi d. Most likely with circumference you'll leave it in terms of pi, but the directions will be specific. It'll either say leave it in terms of pi or round to the nearest tenth. And then when you get to the areas, it's either going to say leave it exact, which means leave roots if there are roots, or round to the nearest tenth, like when you get to the ones that you have to have trig for, obviously you're going to be using trig. Arc length, so the length of the arc was the measure of the arc over 360 times the circumference, or the measure of the arc over 360 times 2 pi r, which is the same thing, or the measure of the arc times 360 times pi d. All of those are interchangeable. So depending on what information you get, you would pick which one you would use. So Jacob. All right, then 11.2. Which was areas of a circle pi r squared and area of a sector. Which is the measure of the arc over 360 times the area, or the measure of the arc over 360 times pi r squared. Added in the areas. So the extra areas that we added in before we got to 11.3. And it's like we said before, some of them we knew. The triangle, which is 1/2 base times height. You're either going to have to know the base and height, like if it's a right triangle, or it would be an isosceles triangle where you have to cut it into 2 pieces, dividing the base into 2 equal parts, and then using the Pythagorean theorem to find the height. That's something that you could see. We had a rectangle, which is length times width or base times height. Parallelogram, same thing. Okay, the difference with the parallelogram is that your height usually had to be found. Okay, in this added formulas, we also went over area of a rhombus, which would be 1/2 diagonal 1 times diagonal 2. So if I had a rhombus, I would take the length of these 2, either multiply them together and then divide by 2, or 1/2 of each. 1/2 of the first diagonal times the whole second diagonal. So you just can't distribute that half to each one. And the last section we did, which was just what we just finished yesterday, 11.3. So to find the central angle, we would do 360 divided by the number of sides. To find the perimeter of a regular polygon, it'd be the number of sides times the length of each side. And then the area of a regular polygon it's 1/2 A and S. A stands for apothem, N for the number of sides, and S for the length of each side, or 1/2 A, which is the apothem, times P for perimeter if you already have the perimeter. And the examples of those were on the beginning of this video. Okay, the review is on Canvas.